How are you, everybody who is watching this video? I would like to take this opportunity to welcome all the physical and online students. My name is Olenjolain. It's the first time to meet me, and I would like to take this opportunity to welcome you into the beauty of Electronics Communication Laboratory. This course is actually we are teaching our physical students in first year undergraduate, or in the first year and third year for ordinary diploma students. It's a very interesting course. It actually builds the concepts in your mind about analog communication system and also about the analog electronics digital communication system. So we have been discussing about the general introductions of this module, and we had actually discussed about a number of concepts. So if you are working or maybe you are very interested on telecommunication engineering or electronics engineering or computer engineering, because communications is almost in every field of electronics engineering. Or maybe you are very interested in biomedical engineering, because even the medical devices they do use to communicate, whether by using the internet, whether by using their Ethernet cable. And also if you are very interested in case of the mechatronic system, which is actually found in most of the industries where you have mechanical system integrated with the electronic system, then I want to tell you that this course is very important for you. So that's just an introduction. We are going to introduce you the concept today. Later on, we'll take you to the simulation part and even the practical part. So just what are the requirements? The fresh mind, actually should have your exercise book, a pen, a pencil, a rubber, a ruler, and then let us go to the interesting business. Let me appreciate about the physical students who are in this class. How are you, students? How are you? Are you ready for the today's workshop? Yes. Well, fine. Hello. What the name of the module? Class, what the name of the module? Electronics, communication, what? Laboratory. And which chapter are we going to discuss today? Constructions of analog communication, what? Circuits. Then this is workshop 6. In terms of arrangement, we began with workshop 0, workshop 1, workshop 2, up to workshop 5. That's what we ended in previous workshop. And this is the workshop 1, according to this topic. And today, I'm going to teach you about the analog communication system. Say analog communication system. Again, say analog communication system. So let me just do the quick review for the students who did not attend the previous workshop. The quick review of workshop 5. So in workshop 5, actually, I taught you about what are the contents of writing what? Engineering, lab, or workshop report. Engineering, lab, or workshop reports and what? And records. And then whenever you want to write any report, There are some parts which are very important. The first one, we say that the title of the experiment, the number of the experiment, and what? The date when the experiment has been done. The second component is what? Class is what? A? Pardon? Speak loudly. What the next C? Components of the lab report. Objective of what? Objective of what? Objective of experiment. Then in the objective of experiments, actual that will be focused on the main objective. In the main objective. We are not focused on the specific. You can break down into different specific objective. And then the next part is what? A theory of what? Of the experiment. And here we say that these are the combinations of laws and what? Principles. Laws and the principles regarding on the what? On that particular what? Experiment. And then I just see link these modules with the previous module that I taught you about electronics communication laboratory, about electronics product fabrication, when we learned about designing the linear power supply. Then the next part, it is what? Pardon? Block diagram. So if you want to define the information about electronics engineering in terms of what? In terms of the song, this we call chorus. And you remember that up to this time, I taught you about general block diagram. I taught you about detailed block diagram. And I taught you about functional block diagram. This isn't? Shane? You are not listening. Then the next part is what? Pardon? Speak loudly. Say description. Descriptions of what? Apparatus or what? Equipments or what? Instrument or what? Etc. Materials and electronics components. Then the next part is what? Procedure. What are the procedures we are going to follow on doing that experiments? Or sometimes we call it what? Method. The next part is called what? Schematic circuit what? Schematic circuit what? Schematic circuit what, class? Diagram. Where we have schematic analog circuit diagram and schematic digital or logical circuit what? Diagram. So we discussed about those information. And this is the very important point that you have to make sure that you apply. Then the next one is what? Measurements. So the next part is measurements. The next one is what? After measurements? Results. Every experiment should have results. Then last is what? Conclusion. And in electronics engineering, we used to conclude the experiment whether they are measured results or simulated results and theoretical results confirm the theory. Whether confirm the theory or whether the results do not confirm what? The theory. So we have just the two status. And it's not a problem for you to say that the results obtained did not confirm the theory and principles. Okay? So if it did not confirm the theory and principle, the next question, why? Why didn't you achieve the desired results? So, now let us go to today's business. Here it is all about analogy, communication, analogy, communication system. Say analogy, communication system. Again, say analogy, communication system. The first question. What is analogy communication system? I know that you have a number of modules that are in this semester. You have 3 modules that teach you about electronics communication, or about, electronics communication system. But what is analog communication system? What do you understand about analog communication system? What does it mean? Take a few seconds to ask yourself, what is analog communication system? Once you ask yourself, just write what you have been thinking on the rough paper. Analog communication system is what? And then I will give you the response of that question. What's going on there? Huh? Class A, analog communication system. So if you know about landline telephone system, where that ourselves, we had the landline telephone system under the rulership of TTCL. That is all about analog communication system, or analog cellular. Just we call it analog telephone system. Okay? So what is it? Write down. Keep on writing. Write down. If your definition is analog communication system is analog communication system. That's the response also. So if you don't anything, you just write on your rough paper, analog communication system is analog communication system. That's what you know. Or you may just write what you are thinking. Analog communication system is what? Is a types of communication system. Yes. You don't have a pen? Yeah, you're still thinking. So some of you are still what? Thinking. But actually you're not thinking, you're just waiting. You're just waiting the response to be written on the on the black. But it's good to think. Well, so I have two, or you can define, there's a different ways that you can define this terminology. But let me just present to you the two ways. The two definitions about this terminology. Analog communication system. Analog communication system, we say that is a communication system. Is a communication system, or is a type of communication system. You can say it's a communication system, or is a type of communication system. Is a type of communication system whereby the information signal, sent from one point to another point. Sent from one point to another point. Sent from one point to another point as analogy signal, through analogy communication system. So analog communication system, please come and sit here. Hello. So analog communication system, this is the type of communication system whereby the information signal sent from one point to another point as analog signal through analog communication system. That's the meanings of analog communication system. Let me give you the second way that you can define this terminology, and then you can analyze about your definition. Analog communication system. Analog communication system, we say that is the type of communication system, whereby the information signal travels, yes, from one point to another point. From one point to another point through the physical means, such as wires and the cables. Such as wires or cables. So these are the two definitions of analog communication system. You can check now, you can go through your previous definition, your thought about analog communication system. Okay, you can refer and then correct it according to what we have presented there. Yes. Hello, stop murmuring, please. I see some small discussion which are not allowed. So we have two definitions of this terminology. This is very important terminology. Remember that, I think that after teaching about digital communication system, then I will challenge you that if digital communication system changed the world, why do we still have analog? That's the next questions that I will ask you. Because for you, you are just learning analog, digital. And then from this time, and even if you watch different movies, different televisions, informations about the technology, you realize that everything that they are mentioning is all about the change, or the digital age. So you may notice that digital technology actually changed the world. But why do we still teach you about analog? Why do we still need analog system? Why should you not phase out the analog system and have digital system? That's the question that I will ask you later on. So you may start to think about that. So the second definition, we say that analog system, this is the type of communication system whereby the information signal travels from one point to another point through the physical means, such as wires or cables. From these second definitions is actual tell us about the medium where this analog information will be transmitted from one point to another point. I think that you've been writing. Listen, stop writing. You've been writing. Some of you have been writing. Let me just review quickly and just build this concept in your mind. Class A, analog communication system. Say analog communication system. Analog communication system is the type of communication system whereby the information signal sent from one point to another point as analog signal, not a digital signal. But through what? Through analog communication system. What does it mean? We cannot send the analog information through digital communication system. Why? Because the digital communication system just understands two states of the signal, either high or low. So in case of the analog, this is a continuous signal. So in case that we have analog communication system integrated with digital communication system, for that case, we should have analog to digital converter that will be converting the analog information into digital signal. Are we together? Are we together? That's the first definition. The second definition, Analog communication system. This is the type of communication system whereby the information signal travel from one point to another point through a physical means. Through a physical means of what? Through a physical means of wires or what? Cables. Wires or what? Cables. So from this second definition actual, you can notice about the type of the media used to transmit analog signal are the communication system. So from this definition, I told that physical means. So what the means of the physical means? It means that the information will be traveling from point A to point B physically. So with the physical media that actually connecting point A to point B. This physical media might be wires or might be what? Cables. So each definition actually build something or build a particular concept in your mind. Are we together? Are we together, class? Wow. So example or examples of analog communication system. Analog communication system. So example of analog communication system is landline. So landline, telephone, landline, telephone system. Say landline telephone system. Say landline telephone system. Yeah, so when you say landline telephone system, actually we say that when you want to transmit information from point A to point B. Then, at point A, we need first of all to have a landline mobile phone, a landline telephone. So a landline telephone, just like this one. And this is just a keypad. This is the keypad. So there should be a cable from this point to another landline telephone system, which this is just representation of the keypad. And again, for this point, we have this one. So for this case, we say that this is the way we call it physical means. Physical means. And for the landline technology, mainly the physical means that we've been using just about copper. So example, copper wires. That's the first example. The second one, we have been using coaxial cables. So coaxial cables. I think that let me just give you some simple examples. So again, example of physical cables or physical means. We means cables or wires used in analogue communication. Analog communication system. So the first one that we use in analog communication system, we use the copper wires. Say copper wires. And these are the parallel wires. So one wire will be acting as a transmitter. The other ones will be used for the reception. So the first one is transmitter. So this is point A, this is point B. So the first wire is transmitting, while the second wire is receiving. For that case, it depends about the form. It might be either half duplex, it might be either simplex, or it might be either what? It might be what? Full duplex. So it depends to the architecture of that analog communication system. Are we together? Okay. Then the second example of physical means, the second example is called the coaxial cables. Because remember from the definition, you say that by the physical means, which is wires or cables. Then the third example, we have something called coaxial cables, copper wires, and then the other ones we call the twisted, coaxial cables, which is sometimes we call them BNC cables. And hence we can transmit this one by using twisted wires. So when you say twisted wires, okay, when you talk about coaxial cables, these are the cables that we are using oftenly to maybe to take a signal from the functional generator to the circuit. Stop writing. When you talk about coaxial cable, possibly that you don't know because this is your first time to hear them. When you talk about coaxial cables, these are the special cables which have a very special way of aligning them and different dimension. Right? We have one conductor, one wire, which is actually be transmitting the information, and the other ones, which is just will be using, will be just receiving the information from another part. Okay? So that is coaxial cable. So the simple example of coaxial cable, it's a cable that we use to take a signal from the function generator to the circuit, or we use to take the signal from the oscilloscope. It means we used to just connect the circuit with the oscilloscope, which we call them BNC connectors. Okay? So you use, I know that you have been using these BNC cables, but actually you didn't check what within. Are we together? So in telecommunication practice or whatever, you may discuss about this one in detail. But in case you need to know them, I can just show you. When you talk about twisted wires, say twisted wires. Say twisted wires. Remember that the copper wires, these are just two parallel wires, which are insulated. One will be acting as to transmit the information from point A to point B. The other ones will be receiving information from point B to point A. So it depends if it is half duplex or simplex or full duplex. Okay? So remember, the intention of learning about analog communication system is not either discuss about half duplex, full duplex, whatever. No. The intention or the point, our main focus here is just to know some examples of the physical means where the analog communication system or analog signal can be transmitted from one point to another point. Right? In case of the twisted wires, these are the physical wires, the two wires. But these wires are have been aligned in the particular, just in the particular way. They have been twisted. And then the other one is just like this one. So this is point A, this is point B. So these are the twisted wires. So it's just like hair dressing when we are dressing the hair, right? To dress the hair, we just need one side, right side, and lefty side. Okay? So can you show an example? No, it's well understood. Yeah, it's well understood. You just want to dress the hairs. You have one, you have some hairs on right side, on your right hand side, and others on the left hand side. So there's a research which has been made to show the difference of transmitting the analog information by using these copper wires and by using the twisted wires. So this one, it has actual more advantages compared to this one. Okay? And if you do your industrial practical training at TTCL, they still have the internet source from their, from their servers to the different clients by using copper. So you can see them. So you can see them, you can lay out, and you can establish the connection. But remember, the strings for the copper wires is actually very, very weak. Okay? Are we together? Are we together? So what will be the carriers of the information signal? If you've understood about the physical means where that we need to transmit the analog information. What will be the carriers? What will carry the information from one point to another point? Can you tell your neighbor? Just tell your neighbor. Let me repeat the question. I have given you examples of what? Examples of diodes. Physical what? Means. Copper wires, coaxial cables, twisted wires. Within a short time, I'm going to teach you about types of analog communication system. So, the question that I've asked you, if the analog communication signal transmitted from point A to point B, or from point B to point A by using wires, or by using coaxial cable, or by using twisted wires, what material will carry the information from one point to another point within those conductors? That's the question. Ask your neighbor and reply your neighbor's response. Okay, I think that some of the students didn't understand. Okay? Didn't understand. Sonia, can you come? Let me demonstrate something and then you reply. So suppose that Sonia is a copper wire. This is a transmitter wire, right? Then Joshua come. Not Joshua. Fatuma Makame. Come here, please. Stop writing. Look this demonstration. Then this is the transmitter. And this is the receiver. Right? And then, Seni come. Can you stand there? This is our destination. This is point B. And myself, I will be the information, the analog information signal. Transmitted by this wire, right? Towards, Sen, can you look on this side? So that's our destination, waiting the information. So myself, I am what? Myself, I am what? Analog information signal. Say analog information signal. Sonia is what? Our transmitting wire. Right? Fatuma Makame is what? Our receiving what? Remember that there is no communication if the transmission and reception is well completed. It's just like a flow of current. There's no flow of current if the loop is open. The loop should be closed. Similarly in communication, there is no any communication if the loop is not closed. If there's no transmission and reception. Are we together? Are we together? So now I am information signal. I have been carried. So carry me. Yeah, see. Is Sonia carrying me from this point to that point? Right? Right? But remember, these are the wires actually laid physically to that destination, right? So assume that Sonia is the wire from this point to that point, right? So actually I'll be moving to this point. Okay? Or let Sonia just push me. So I'll be moved. Okay? Then now, Fatuma come this side. So Fatuma will push me to the receiving wire. So if that is completed, then the communication has been what? Established. So the question now, when you come for these wires, what will be carrying the information? Which part will be carrying the information? Will be transmitting information from one point to another point. Did you understand first of all this demonstration? Okay, clap your hand for these guys. Thank you. Thank you. Thank you. So now tell your neighbor. Get it. So what will be carrying the information, the analog information? Tell me. Tell your neighbor, please. What? How do we, what the name? Right? The name of the information, the carrier of analog information. Baba, go and sit there. The name is Sonia for the transmitter. The name for the receiver was what? Fatuma Makame. What will be carrying information from here to here? Quickly, please. I want to move to the next part. Who can try? Raise up your hand. You can try. Eliakimu. Try. Electrical signal. Yes, electrical signal. It means those analog information signal are electric in nature. They are not light. They are not heat. So they're electrical in nature. So the nature of the signal, it is true electric signal. What will be carrying that electric signal from one point to another point? The answer is very, 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 very simple. The answer you just learnt in DC current, and you learnt in atomic physics the first part called the electron. You had a subtopic in atomic physics. Atomic physics has 4 subtopics in A level. The first one is electron. The second one is what? Boas. Or it's called quantum physics. The third one is called what? Nuclear physics. The first one is called what? Radioactivity. So in electron, we taught you that electrons are the one used to carry electric signal in a conductor from one point to another point. That's all. And we taught you in DC current about 3 types of material we have in electrical. The first one is called what? Conductor. The second one is called what? Semiconductor. The third one is called what? Insulator. So what are the current carriers in conductors? Electrons. Right? What are the current carriers in semiconductor? Electrons and what? Holes. So you just enjoy that transmission of analog signal, and then you don't know what will be carrying. And in heat, we taught you about relaxation times in current also, about relaxation time. And in current, in DC current, we taught you that the current can be transmitted from this point to this point by the physical movement of electron or by vibration. We taught you that concept in heat, Form 5, Physics Form 5, and we taught you in current, where we taught you how you can calculate what relaxation what time. And that the first part of what DC current. But you forgot, you failed to link. So the carriers of analog information signal is what? So the analogy, let me write for you, because you forgot a lot. The analogy information signal is carried from one point to another point by electrons. That's what I asked you, and that's what I told you to tell your neighbor. But I think that you know what did you tell your neighbor. Can you refer what your neighbor told you? Can you refer? Can you refer your neighbor's story about that question? Oh, your neighbor was quiet at all. I told you that whenever you come to my classes, try your level best to choose a correct and a right neighbor who can help you to answer the questions. Okay, so this is all about the overview or the introductions about analog communication system. Then the next part now is types of analogy, types of analogy communication, types of analogy communication system. Types of analogy communication system. So in electronics engineering, and the communication engineering, there are two main types of analog communication system. Namely, the first one, our communication system, depending on the nature of transmission, medium. So in electronics and the communication or telecommunication engineering, we have two types of analog communication system. The first one we classify them depending on what is say nature. Say nature. Nature of what? Transmission what? Media. Huh? So the first one, we call it guided. Guided analog communication system. Guided analog communication system. The second one, we call it unguided analog communication system. So class A, guided analog communication system. Class A again loudly, guided analog communication system. Again, class A, unguided analog communication system. Getting? So this guided analog communication system, sometimes we call it wired. Wired analog communication system. And this one, sometimes we call it wireless analog communication system. So we say that this is the note before. Any telecommunication or communication system okay, get it. Consists three main parts. Any telecommunication or communication system consists three main parts. The first one is called the transmitter unit. The second one is called the media, or sometimes we call it in singular, we call it media or medium. Singular, medium. Plural, media. Then the third one, or the third part, is receiver unit. And I've introduced this concept when I've been teaching you about electronics product fabrication. Class A, transmitter unit. Say transmitter unit. Class A, media. Say media. Others they cannot see on the blackboard. So that's why that we pronounce for them but also pronounced for you to write this information in your mind for the rest of your life. Then say receiver unit. Class A, receiver unit. So whenever you think about designing or implementing or troubleshooting or analyzing any telecommunication or communication system, think about those three parts. Otherwise, you'll get a challenge because you won't know that whether you are using the part which is called which is responsible for transmission, or you are dealing with the part which is responsible for the media, or whether that you are using the part which is actual receiver unit. And a simple example, for instance, if Johanna calls you, so Johanna mobile phone will be acting as a transmitter. Or let's say that if Johanna sends a message to you, then Johanna's mobile phone will be standing in the transmitter part. Then the media for that case will be wireless. Okay? And the wireless is not general. There's a particular frequency or bandwidth allocated for the messaging and calls, or for the mobile phone communication, which we call it in telecommunication or electronics engineering, we call it the cellular network. Okay? So that will be the media. So the media will be wireless, because now Johanna Samandito cannot call his auntie or his sister or his young sister or his previous teacher of secondary in Geita by using wire. Okay? Then the receiver mobile phone will be acting as what? So let's say that Johanna Samandito has called his teacher. So this mobile phone will be acting as a receiver unit. Then if Johanna's secondary teacher replied the message, Johanna's secondary mobile phones will act as a transmitter, and the media still the cellular or wireless, and the Johanna's mobile phone for that part will be acting as what? As a receiver. That's the simple wireless or simple example of wireless communication. In case of the wired, it's simple to give you a simple communication that you are using every day. But possibly I've never thought that it's all about telecommunication, also all about communication. For instance, we have a student here whose name is called Precious. Precious wanted to transmit a folder of a folder of electronics communication laboratory from her computer to the to her mobile phone. So for that case, she will be using either, let's say that she will be preferring to use a USB cable, right? So because the file will be transmitted from Precious computer towards Precious mobile phone. Then for that case, Precious computer will act as a transmitter unit. And then the medium of communication, because for there you will just have a single medium. So we call it medium, we don't call it media. Media, it's plural. That's why you hear that we call radio broadcasters, we call them hawa ni watu wa media, si ndio? Nasemaga tu jina media, lakini uelewi kwamba media ni nini. Sawa? Why? Because the content creators, and they'll be transmitting by using transmitters and propagate the information to be accessed by the different receivers. Then the media for communication for that case, it will be USB cable, which consists either 4 wires or 2 wires. 2 wires for power, 2 wires for transmitting and receiving information. Then Precious mobile phone for that times will act as receiver. Simple like that. If then Precious want to transmit one song from her mobile phone into the computer, then Precious mobile phone will act as a transmitter for that case, and the media will still be the USB cable, and then Precious computer will act as a receiver unit. So we are always using telecommunication system or communication system in our daily life. So if really you will graduate your undergraduate studies for the 4 years, and then you have never even designed a simple telecommunication system, for that case, will be very disappointed. And you yourself, you have to be also very disappointed. Because you learned about telecommunication engineering, but you covered nothing. Hello? Chap. Okay. So, we have covered about, say transmitter unit again. Say transmitter unity. Say medium. Receiver unity. Tell your neighbor, make sure that tonight you dream about this information. Then, our intention, we are focusing on, yes, we call them technical system. Hello? Join. Okay, then this module will actually focus on technical information. So we need to have technical information. Right now, it's your responsibility to go and find what the means of guided analog communication was unguided. For me, let me just share with you about technical information, which can help you to understand about the guided analog communication system. And then, ladies and gentlemen, now let me teach you about block diagram. Block diagram of what? Block diagram of guided or wired analog communication system. So what the architecture of analog communication, of guided analog communication system? What it's the architecture? But before I teach you about this one, let me just teach you general. Because maybe you forgot or you haven't been taught. General block diagram of analogy of what? Of communication system. General block diagram of communication system. Mostly communication system. Most electronics communication system consisting the following parts. The first part, we say that in any communication system, we need information. Information, or sometimes we call it a message. We'll come back to analog communication system. So this one we use called the message, the block for the message. You know that the block diagrams is actual. We draw it by using different blocks, and those different blocks, they should be interconnected, and we use the arrows to interconnect them, and the interconnection should be just the way you want them. But interconnections is actual, should be logical, according to what has been planned. So message or a block of 40 information. Then the next block is called the transmitter. Transmitter unit. Then the next block is called the media or media. Then the next block is called the noise. Then the next block is called the receiver. Receiver unit. Then the next block is called the destination. Destination or receiver part. So the general block diagram consists of 60 blocks. Subwriting, subdrawing. We cannot have a communication system or telecommunication system if we don't have the information we want to transmit or we want to receive. I said stop drawing, stop writing. Lucy, you are losing. So the message or the information signal is actual processed, and once it's been processed until we have a desired information signal, then it's delivered to the transmitter unit. Okay? Then, afterwards, once the information has been processed by the transmitter, including the issue of modulation, if it is the media is wireless, and including the information supporting or including different process about the preamplifier, about the power amplifier, about actual that we call it low signal, we call it low noise amplifiers and whatever. We have different blocks in transmitter depending on what on which type of the transistor. Sometimes you can have local oscillators. We have different parts. Then the information will be delivered to the media. Before the information passes to the next block, the media can be affected by the noise. And when we talk about noise, we don't mean about the noise of the horn, such as car horns, or maybe the noise when you are talking, when you're from Fatuma. Okay? So when we talk about noise, when we talk about electronics noise or communication noise, we don't mean about, maybe for instance, I'm teaching, and then the students are making noises. We don't mean about that. But it's an electrical signal, but it's not required. It's unwanted signal, right? It's electrical signal. It might have maybe the same properties as the information signal, or sometimes might have different properties compared to the information signal. So always, any media is actually exposed to the noise. Say noise. Most students, they used to draw that general block diagrams by using only 5 blocks. They forget about noise. When it comes for the telecommunication or just communication system, noise should be taken into consideration. And that's why we have a parameter called the signal to noise ratio. So what will be the strength of the signal received by the receiver unit once the signal has been affected by noise? For instance, if for instance that I want to walk from here to this point, but I have got tired. So you know that tiredness will act as a noise to me. Because I'm tired to move, but I have to move. Right? So tiredness will act as the unrequired situation. That's why you have to take a rest, or something you have to drink energy. Energy? And I think your neighbor has it on table, on his or her table. Then, once the media process the information, then it will be sent it to the next part, which is what? Receiver what? Receiver what? Receiver what? Yeah, receiver unit. Then the receiver unit will process the information, and also it consists of different parts, including low noise preamplifier, low noise or small signal amplifiers, including some differentiators, including some So it depends. Some multiplexer, it includes sometimes the multiplexer, it can consist of some decoders. So the number of blocks within that. Then, once the information has been processed, it will be sent to the what? Destination. Say destination. Say destination. So, in this part, I introduced about 3 main parts of communication system. In this part now, I have introduced you about 6 main parts, or 6 parts. So we are moving. Right? Right? So remember in the first, from the first point, the first part, which is transmitter units, actually we combine this block and this block. The second part, we combine the, it's just noise. We combine noise and media. The third part, we combine destination and DOT and receiver. Okay, so let us move on. So, I think that when I mentioned the 3 main parts, I did not draw the block diagram. So, general block diagrams of of communication system. So, this is a kind. Remember that the first part, we say that when we ask, this is the common. Most telecommunication engineers, they just know this one. And you should not have a battle with them. Right? If, for instance, myself have been asked to present about communication system, Dominic, if I've been asked to present a communication system, always, and I have to use the language of diagrams, because engineering is all about diagram, for me, I will start with only 3 blocks. Then I will move to these 60 blocks. Then I will move up to the 20 blocks. That is my philosophy. I don't know about yours. That is my own, to start from the simple concept to the advanced concept. Possibly yours, it is vice versa. That is fine. It's fine. So this is the first block that you have to draw before this one. So here we have what? We have what? Pardon? We have transmitter. Here we have what? Media. And then here we have what? Receiver what? Unit. And then here we have, they have been interconnected. They have been interconnected. So this is the first block diagram that you have to draw before this one. I do this because I know for you, sometimes you learn this information in order to answer questions in the exam. So for the sake of answering questions in the exam, if you've been asked that to draw the general block diagrams of communication, telecommunication system, there it is. But for the sake of understanding and developing your proposed solutions to solve maybe existing a real-life communication system problem, then that's the first one. Then you come for that one, and then you continue up to the number of blocks according to your design. Are we together? Okay. So for me, this is figure 1. Figure 1. The general block diagram of 40 of, okay, let's mention the course that you are studying, telecommunication system, because possibly you might be happy. If I mention communication system, I say, no, for me I'm not learning communication system, I'm just learning telecom. So this is figure 2. Figure 2. Also, this is the general block diagram. And I taught you about block diagram of 40 telecommunication system. I taught you about block diagram in first semester. I don't know how further have you gone. But I told you that the engineering language. So let me relate in figure 1 and figure 2. Then let us move the next part. Stop writing. This block, once we have opened the transmitter unit block, we have found the message or information, the block for the message, and we have found the block for the transmitter unit. Right? Then when we open the block of media or medium, we found the media or medium and a block of noise. Eliakimu, Matthias. Then when you open the block of receiver unit, Then we found that we have receiver, unity, and destination. Simple like that. No need for you to cram them or to spend the whole night. You are just learning those two block diagrams. It will be a shame. Okay? Well, good. So let us move. The general block diagram. I told you from the beginning, engineering is all about what? It's all about what, my beloved students? Numbers. And then what? A diagram. What? Schematic. Pardon? A schematic levels. A pardon? Tables. The other component of engineering language is what? A graphs. The other component? Formula and what? Mathematical equation. There's no way out that I can teach you about electronics engineering and telecommunication engineering without using those 5 terminology. Whether you like or you don't like. It's not a matter of myself, it's a matter of the reality. Okay? So then we have covered about general block diagrams of communication system, and they've covered about a little bit detailed block diagrams of communication system, whether it is analog communication system or digital communication system. I said stop writing. Remember that. These are the general block diagrams for any telecommunication system, whether it is analog communication system or digital communication system, whether it is guided analog or digital communication system or unguided analog or digital communication system. Similarly, for this case, you should not confuse these arrows. I will transfer you within a time or within a while about the block diagrams of what I will teach about of unguided. I will show you the difference that actually we have to show the difference by just because in unguided we need antennas. So I'll show you the difference. But for the time being, whenever you think about any telecommunication system, think about that block, think about this one. If I could be you, I could be reviewing and make sure that to write in your mind for the rest of your life. Whether you're talking about fiber communication, whether you want to learn about cellular communication, whether you want to learn about Ethernet, whatever means or system that you'll be learning, these blocks will come into play in your mind. Are we together? Well. So say general block diagrams of guided analog communication system. So we are going back to where we ended. Right? Yes, because I've just ignited this concept because I did not discuss or we did not discuss earlier. So I want you to be aware of that, of this concept. Maybe you have learned in other modules, but it's better to give you the overview. So, stop writing. To draw the general block diagrams of guided analog communication system, it's very simple. I say this, stop writing, stop drawing. Listen and watch. And stop chatting, because I see some of you are chatting. To draw the general block diagrams of guided analog communication system, there is no need for you to cram it. Simple. Because we develop from the figure 2. Right? We just extend what you have in the second figure. That is all. And that's the goodness of discussing or learning engineering concept by using diagrams. Because simplify life and actually give you. For instance, if you use this one or this block, it's very simple for you to build the definitions of communication system. Even if that you don't know how to define it. Even if you didn't read it. Once you have the block, you know, aha, I've been asked you to define what? Communication system. How can I define? So you define and you draw the block diagram. The concept is well understood. Right? Oh. So, the first block for this case, I say it is stop drawing, look, listen. What the first block here? What the first block here? Or what? Information. Ask your neighbor, do you have information today? Ask your neighbor, because you want to transmit that information. Do you have any information so that you can transmit today? No. Okay. Then, for this block, I said stop writing, stop drawing, look. For this block of transmitter unit, we can open and have other two main blocks. Winfrida, the first block is this one. This is called the input transducer. Input transducer. Say input transducer. But also still have a block. I said stop writing, and then Eliakim is now he starting to write. He's starting to write. The next block is called what? Pardon? Transmitter unit. So input transducer, transmitter, this block of transmitter unit and this block of meso information, they come from this general block. And then if you relate these three blocks with what we have drawn here, the block of transmitter unit, we just opened and find two blocks. Input unit and the transmitter unit. Are we together? Are we together? Samuel, Ringo? Okay. Continue on what you are doing. We have an arrow. So we have a message we have to deliver to the input transducer. In any communication system, a transducer is compulsory. Okay? Then we have also another arrow to the transmitter unit. Ha, 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 ha. Then for the media, listen. I have students who are very expert in cramming. I'm trying to help them not to cram. But they say, no, sir, don't help us to cram. We like to cram a lot. Media. Medium. And here we have media. Then we have another block. So media, we just have it here. And here, have a very interesting block. This block is called noise. Then we have another block, which is not shown in the other previous blocks. This block, there's no way out we can say that we design a communication unit and then there is no supply of electric energy, because no any electronics communication system which can work without electrical power. So if you could be reasoning and link the concept that I taught you, that there is no any electrical or electronic system or telecommunication system that can be used without the need of power. Without the need of what? The need of power. Okay? Yeah, so what you have been missing there, very important. Because if we don't introduce you this concept, you might think, okay, so if I build a transmitter, that's all. Just a message, I have a message, I have a media, I have receiver, I have this, that is all. All of these blocks, this one, and this one, and this one, and sometimes if this is guided, they cannot work without power. Or without electric energy. Right? So what has been missing there? Power supply. But you have never think about that, because for you, you are always accepting. Getting? You are always accepting. Power supply, what? Unit. So Sonia, I said stop writing. You have been Soniaing. Now you wake up, and now you are writing. Well, keep it up. Then we have another block. This is called receiver unit. Then we have another block which you call it output transducer. Say output transducer. Say output transducer. Then now we have our another block. And this block is called the destination. So how many blocks do you have there? I remember it's the same class when I taught you from the concept of the 4 blocks until we had the 13 blocks. But unfortunately, you never practiced about some other parts. You left it where I ended. Well, so how many blocks do you have here? 9. I didn't say draw. I say listen, watch. Then the message, once they be processed, for instance, if the video signal or audio signal, it has to be actual processed and edited, etc., combined about just the information from this microphone, from that microphone, combined together and make one message or information signal. Then we feed the information into the input transducer, and once the input transducer performs function of transducing from the real world physical quantity into electric signal, deliver the output. Zuena Masebo, deliver the output to what? Transmitter unit. Rollins. Then, after the transmitter unit perform its function, deliver its output to the next block, which is called what? Media. But remember that this medium or media, it's a guided media. So for instance here, you can say that, yes, I think that I forgot, very important, guided what? Guided what? Medium. Or guided what? Media. Because sometimes information might be transmitted from either guided, one guided media to another guided media to another guided media to another guided media until it reaches what? To the destination point. Ruben, go and Ruben there. Then, so once the media transmits the information from the transmitter unit to the receiver unit, at the same time, remember that the noise affects the information within the guided medium or media. Okay? But remember that this input transducer cannot work without electric power. And remember that the transmitter unit cannot work without electrical power. Sometimes a media also needs some electrical power, but let us just ignore it for the time being. Remember that noise does not need electrical power for it to work. Then, we have again another block. So another block, we say that the receiver unit will never perform its function if it does not have electric power. Once the receiver unit processes the received signal, which in most cases it's a low power signal rather than the high power signal transmitted by the transmitter, then it delivers its output to the output transducer. Once the transducer performs function, then deliver the information to the OT. To the OT? To the OT? To the OT? I gave you some example of guided media. Copper wire, coaxial cable, twisted wire, optic fiber. And you went to the study visit of optic fiber. I know it. But you've been surprised. So this is figure 3. So this is general block diagram of guided analog communication system. Are we together? Are we together? Draw it. If you have a question, ask it. Okay, so we have been discussing about, firstly, I think that I just told you we forgot to supply the power from the power supply unit to the output transducer. We've been talking about separating. We've been talking about blocks and interconnection, logical interconnection from one block to another block. Right? Right? We didn't talk about the information signal or the signal, which I said is stop drawing, stop writing, stop doing whatever you're doing, listen, watch. So then we are going to have another discussion to study about the signal which will be transmitted by these arrows. So here we expect to have analog information or analog information signal. So this is, at this point we have analog information I signal. Also here we still have analog information signal. Analog electrical information signal. At this point, we call this message transmitted analog signal. I'm going to use the abbreviations because of the space I have. This one is what, class? Pardon? Shane, yourself. This is what? Shane, yourself. This is what? You haven't been in the class. What? This one? This one? Very good. So this is analog information signal. This is what? Analog information signal. Why it is analog information? But remember, this is analog electrical signal. Remember that the signal or this analog information signal, it might be either electrical or it might be another form. It might be sound, which is mechanical signal. It might be video, which is light signal. Right? Yeah? It might be text. But remember, for analog systems, to transfer text is a little bit challenging. But sound or audio, or it means that voice and video, it's possible. So the function of input transducer is actual to transduce the received signal from the message source or source of the information or the message into electrical form. So the output of the... Hello, students, I say listen and watch. Lucy was not totally in this class. Can I have what is actually taking you out of the class? Give me, please. Give me that mobile phone. Give me. Thank you. Protect it. Listen, I said, because I think that you will be discussing about digital communication system later. I said, the message might be either in electrical form or in other form. So this input transducer, the main responsibility transducer, it's actually combinations of the two power, or two terms. But transducer, the main function of the transducer, first of all, the principle of operation or the law that we apply to design any transducer is the one that we learned in physics that called the principle of energy. Principle of energy what? Conservation. Which is said that energy can neither nor but it can be transformed from one form to another. So the main function of input transducer to transduce the analog information signal from the source of the message into electric form. Mvunye? So, at this point, we have a little bit analog information signal, which might be either the same to what will be received in the input transducer or different. But what we are sure for this part, we have analog electrical information signal. That's why we have input transducer. Are we together? Then, once the transmitter unit receives the analog electrical information signal, process it, and then deliver its output. Lucy deliver its output to Lucy. Deliver its output to what? To Lucy. To the guided medium or guided medium. Are we together? So this signal, we will not call it anymore analog information signal. We just call it transmitted analog signal. So in each part, remember that if it could be you, I could even sometimes go and study one of the system. I could add some graph or some waveform on top of it because it simplifies your level of understanding, especially to relate the theory and practical. Right? Right? So the media will be receiving a transmitted analog signal, and then it is actual transmit. The media will not do anything rather than transmitting the signal. So for this case, then the information signal will be actual, the transmitted analog information signal will be sent to the receiver unit. But remember that when the power supply is working and it powering all of those blocks, then if that's the case, once the receiver unit transmit or process the information, then this information signal will be, we will call it received analog signal. Listen. If you don't listen, you just write RAS. After 2 weeks, you don't know what the long terms of RAS. That's why I told you that pay attention. Then, once the output transducer, remember that the input of output transducer is electric signal. But the output might be either electric signal or other form of signals. That the meaning is because the transducer is actually nothing. Transducer is electric or electronics device that is converting one form of energy into another form of energy. That's all. And right now I'm using a microphone. This is the transducer. And it's the input transducer. Right? Are we together? Well, so then this is received analog signal. Once the output transducer processes the information, we are going to have what we have transmitted. This one we'll call it analog information signal. If you transmitted the audio, we expect at the destination to receive the audio. If you transmit audio of 100 Hz, we expect to receive an audio of 100 Hz. By that, if you achieve that, then we say we have achieved it to design a guided analog communication system. Otherwise, our design is wrong. Are we together? But also remember that this system will never work without electrical power. So what do we say? The input transducer need power signal. The transmitter unity need power signal. Then we have what? The receiver unity need power signal. The output transducer need power signal. That's all. So this one we call it noise signal. Noise what? Noise what? Everything is well explained. In exam, don't write with those abbreviations. Because I know that you'll claim TAS, A-I-S, A-I-S. Then TAS. Then RAS. Okay. Okay, that is all about the general block diagrams of guided analog communication system. If you have a question, ask it. If there's no question, let me move to the next block. Do you have a question? Johanna, do you have a question? Now let us move to the next part of unguided analog communication system. unguided analog communication system. Say unguided analog communication system. So this unguided analog communication system, sometimes is the one that we call wireless. Wireless analog communication system. What is it? So unguided wireless or wireless analog communication system, what does it mean? What the meaning of unguided or wireless analog communication system? So we have this definition. Unguided analog communication system, we say that is the type of analog communication system in which the analog signal is transmitted through the unguided or wireless communication medium. So unguided analog communication system, we say that this is the type of analog communication system in which the analog signal is transmitted through unguided or wireless communication medium. So the nature of the signal, first of all, is analog. The nature of the transmitter or input transducer or output and the output transducer, transmitter unity and receiver unity, all of them are the analog circuits. So example of unguided medium is space or air. That's the simple example of unguided medium. Examples of guided media are four. Twisted, we call them twisted pair. I think that I forgot. I just wrote twisted wires. We call them twisted pair wires. Twisted pairs. Because one pair, it means that one wire is transmitter and the other one is receiver. So we call them twisted pair wires. The second example of guided medium or guided media is what? A coaxial cables. The third example is what? A, pardon? Pardon? Copper wire. The first example, however, that we don't use it in an analog communication system, is called the optic fiber. That's the first example of guided media. So let me just say, right. Light for you, because I love you. Examples of what? Of guided. Example of guided media are, the first one, we call it copper wire. Copper wire. The second one, we call it twisted pair wire. The third one, we call it coaxial cable. And the first example is called the optic fiber. But remember that I have mentioned examples of guided media. These are the ones we are using for the analog. Optic fiber, that's another story. We often use optic fiber for the digital communication system. Are we together? Wow. Then the next part, general block diagram of, you have a question? Welcome. Pardon? Same noise and what? Huh? You say there's two types of noise. The first one is what? Internal noise and the external noise.
From the internal noise, you have two. That is the short noise and the thermal noise. How do these noises are being created in optic fiber?
I'm not teaching about optic fiber. I'm not teaching about optic fiber. I just mentioned optic fiber as one of the examples of unguided media. That's all. So Eliakimu's question is, he said that we know that we have two types of noises, external noise and internal noise. And also we have two types of internal noise. Isn't it? And then he said that how can we discuss about those two types of internal noise on regard with optic fiber? The response, I'm not teaching about optic fiber. The good news, you'll have a module that's called the optic fiber. During your NTA level 8, it will be your 4th year. It's a module, you'll learn it in one semester. Okay? So when we have been taking you to the study visit, we actually made you to be leading ahead. But we know that for the Bongo people, by that time, you don't remember what you saw in study. So then, ladies and gentlemen, let us discuss about general block diagram of unguided analog communication system. So its nature is just the same. We have a message or information signal. This is input transducer. We have a transmitter unit. And hence, for this case, for this part, we are going to have stop writing, stop drawing. For this part, we are going to have unguided media. I think that let me change everything. So we have a block. Pili is, class Pili is what? Pili is what? Pili. Unguided. This is unguided media, or it can be more than one media, or unguided media. Unguided media or unguided media. So now, the media or the transmitter, I said stop drawing, stop doing whatever you are doing, and stop being disappointed or being unhappy. For the unguided analog communication system, the media or medium is actual interfaced with the transmitter unit by using a very important part which we call the antenna. This is what we call the transmitting antenna. Transmitting what, class? Transmitting what? Antenna. So the final part or the last part or the output of the transmitter unit will be the transmitting antenna. Sending what? Electromagnetic waves through the unguided media. And the media, or remember that the media is also affected, or the media is affected by noise. The media is affected by noise. So this is what we call the noise signal. So for this case, what we are going to have here, it means that you can use this symbol to show that waves or electromagnetic waves, those are not there. And here we have transmitted analog signal. So the media will be actual transmit and broadcast. Broadcasting to the receiver. So the receiver also receives the information by using a very important part, which we call in electronics and telecommunication, receiver antenna. So remember, this is just to show you. But actually in the block diagram, we don't need this. Once you have this symbol of the transmitting antenna, it's enough. Just want to show that for this case, we propagate electromagnetic waves. Then here we have our receiving antenna. So let me just, because I know some students, they have parallax, they can have parallax error. To say that the receiving antenna is connected with noise. Yes, the receiving antenna also is interfaced with noise because it is outside of the block of the receiving antenna. So here we have this block. This one is called the RX antenna. So there is no any physical connection between the transmitter unit of the guided analog communication system and the receiver unit of guided analog communication system. Are we together? Class, are we together? This is figure what? Figure what? 4. General block diagram of what? Unguided analog communication system. Unguided what? Unguided what? Unguided what? Say unguided analog communication system. Again, say it loudly. Some of you are slumbering. Say unguided analog communication system. Unguided analog communication system. Yes, so your loud voice can wake up somebody or your neighbor who is slumbering accidentally. So, for this case, we expect that to receive the signal here, which we call to receive the analog signal. Are we together? Yeah, so the principle or the difference is just the interface between the transmitter unit and the media. Between the media unit and the receiver unit. Ruben now is drawing. I didn't say that's the time for drawing. For if I could be you, I could go back to the figure number 1, and hence when I want to teach, or I want to learn, or I want to categorize about the type of the communication system I'm focusing about, I could say that we have two types of communication system. The first one is analog communication system. The second one is digital communication system. So I can draw the general block diagram of analog communication system. How? All of these blocks, I will make one block that's called transmitter unit. Then that block of transmitter unit, I will connect the transmitting antenna. And then I will have a media, and the third block is what? Receiver unit. Remember, the media is a communication, for the figure 1, is combining what? Is a combination of noise and what? Media. So when you talk about unguided, then when you talk about unguided, we talk about antennas. When you talk about what? No physical means of connecting one unit with another. Are we together? Okay. Ask a question. If you have a question about what we've discussed, ask it. If you don't, draw it, because that's another diagram. Okay, stop writing and stop drawing. Johanna Samandito asked me a question. One of our interested engineer from Geita in Tanzania. Johanna's question is about this, the general block diagram of unguided analog communication system. I said stop writing, stop drawing. Then, his question is focused on this block, about input transducer. Fatuma. Then his question said that, when you've been discussing about the general block diagrams of guided analog communication system, then he understood that the input transducer will be something transducing one form of energy into another form, but that another form is not electromagnetic wave. So according to what Johanna has understood about guided, then he said that what he has expected for the general block diagrams of the guided and unguided analog communication system, the input transducer to be the antenna. So now he asked me a question. Why an antenna now is acting as the output of the transmitter unit and not the input transducer? So that is Johanna's question. Did I quote you well? So listen. Johanna asked the question that about the general block diagrams of unguided analog communication system and guided analog communication system. Then the question was actually focusing two blocks. The first one, input transducer and the transmitting antenna. Then the question is, he expected this, the general block diagrams of unguided analog communication system to be, or the input transducer to be the antenna. While now the antenna, it's the output of the transmitter unit. So the answer is this one, simple. The message might be in electric form or in other form. of energy. That's why we need the input transducer to convey any message signal, whether it is text, but remember that for analog we don't have text, mostly whether it is voice or video, then it conveys into electric signal. Remember, voice is mechanical signal, right? And video, it's light signal. So whether we have a video camera, like the one that I'm recording here, the information, so the video camera acts as a transducer, input transducer. Johanna, I'm answering your question. If it is voice, the microphone like the one that I wear, right? The main function of input transducer to convey any other form of message signal into electric signal. So the transmitter unit will never understand any mechanical signal, any light signal, any heat signal, any kinds of other signal rather than electric signal. That's why we need this one, right? And then the transmitter do everything, just modulation, does the encoding, does a lot of functions, just sometimes that just have the carrier signal in the whatever, and doing a lot, just minimize the internal noise within the system. Then the output of the transmitter will be fed to the antenna. Antenna is also one example of telecommunication transducer. What does it transduce? Okay, so let us discuss about what will be propagated here. Light wave or light signal, it has 7 spectra. The first one, radio frequency. The second one, microwave. The third one, infrared. The third one, visible light. The fourth one, ultraviolet light. The sixth one, X-ray. Next, gamma rays. But X-ray is always the last one. Gamma rays is the 6th and the X-ray is the last one, according to what? Frequency and wavelengths. Fine. But in wireless communication, we are just using 3 spectrum. The first one, radio frequency, which in short we call it RF. The second one, microwave. And the third one, infrared, or we call it IR. And simple to realize them. For instance, right now, the transmitter you have and receiver using RF, right? Then whenever you see any telecommunication-based transceiver station, we call it BTS or telecommunication tower, there we have some small dishes. Those small dishes are microwave dish link, right? In case of infrared, simple. Remember about the television receiver, remote. That is infrared and need the line of sight. Are we together? But so it depends for the antenna, whether it is radiating radio frequency or microwave or infrared. Are we together? Then next, then the media will be interrupted with noise. And then finally, the information will be received by receiving antenna. Remember, receiving antenna, it's also a transducer. That is transducing light or electromagnetic waves into Remember that if you have RF transmitter, we must have RF receiver. If you have RF microwave transmitter, we must have microwave receiver. If you have infrared transmitter, we must have infrared receiver. There is no any means that you can interface one spectrum with another spectrum. That's why we want to teach you about the secrets that have been hidden. So this one will be transducing light energy, which contains carrier wave and information signal into electric signal. Receiver unit will never understand any other form of signal rather than electric signal. It processes what has been received and then receive and then deliver its information in output transducer. So the output transducer conveys electric signal into electric signal or into other form. If it is this one, we say that a speaker. It will be converting audio signal, electric audio signal, into sound signal. If this one, we say it's the display. It will be converting the light signal from the receiver into or the electric signal into light signal. That's why you see the video or the still pictures. Are we together? So when you talk about transducers, actually it's a huge discussion. I think that I've tried my level best to give even you information which I didn't plan to give you, but because one student asked that questions, I used also to teach some concept as long as students have a need to understand. Finally, let us end our workshop 6 or workshop 1. We said that, so if this is the case, I've talked about guided and guided analog communication system, the component for the transmitter unit and the component for the receiver unit are the following. So the following are the some components of transmitter and the receiver unit of analogue communication system. Analog communication system. So the first one, in most of those analog communication systems, one of the important part is called the amplifier. Say amplifier. Class, say amplifier. Another electronics communication components that we need whenever we want to construct analog communication circuit is called the filter. Then filter, its main function is actually to filter the noise and unwanted signal. Another components, we call it differentiator. Then another components or another important part, we call it integrator. And another important part, we call it oscillator. According to this model, we have been told that, or we have been given the responsibility to go through the following 5 parts. So how are we going to go through them? Just stay connected, and I will tell you the plan. So remember that the amplifier is an important part of the transmitter unit. It's an important part of the receiver unit. Hello? I say it's operating. The filter, it's not much important in transmitter unit, but it's compulsory for the receiver unit. Then differentiator depends. This one, it might be important in transmitter unit. It might be also important in receiver unit, because its main function is actually to differentiate the electric signal. Then the next one, integrator. It might be important in transmitter unit. It might be important in receiver unit. Depends on your design. Why? Because this one integrates the information signal. And that's the applications of mathematics you learned. Then we come for the oscillator. This is important in transmitter unit. Oscillator is important in receiver unit. I know most students, they used to claim that oscillator is important in transmitter unit to just produce or generate the carrier signal. But I want to tell you another secret from today. In some of the receivers, we need a type of oscillator that's called the local oscillators. So because that you wanted to find the simplest ways to claim, but you want to transform you from claiming, try to understand and try to know the purpose of each part whenever that you are discussing about it, whether introductory or intermediate or advanced. Class, is it clear? Is it clear? Okay. Did you understand? Did you understand the workshop 6 or workshop 1? Okay, it's time for me to appreciate you for understanding. So that clap that you are going to make, you appreciate yourself for understanding what I've told you. 1, 2, 3. Hongera. Imara. Wow. So I congratulated you who are physically in this class, and also I congratulate those who are not physically in this class. This is the end of workshop 6 in series of workshop 0 to 5, or workshop 1 in context of constructions of analog electronics communication circuits. I would like to invite you in the next workshop, which will be workshop 7 or workshop 2 for this one, where that we are going to discuss about communication circuits, about communication amplifier circuit. So, you know, or we have different types of amplifiers, but we don't use all the electronics amplifier in communication. We just use some of them. So in the next workshop, I will teach you some of the electronics communication amplifiers that we are using them in designing the transformer.